Join discord.gg/flat earth and enter a VC check-in room, and someone will come along to VC verify you to get involved with the conversation about our earth.
SantiagoDunbar.
Hundreds of miles.
That's not actually true. A lot of the antennas that the military uses are shaped in a pyramid to specifically, as they're told, and I have a friend who told me this without knowing that I'm interested in the flat Earth. He said, we set this up like a pyramid to bounce it off of the Earth's ionosphere, right? So they're bouncing rays upwards, right?
Yep.
In order for it to go further than the curve, right?
But you're talking about radio waves. You're not talking about ballistics.
Direct line of sight.
You're not bouncing
direct line of
like
sight
ballistics
laser
off
targeting.
of the ionosphere. Sorry,
No, I'm talking about radio waves, yeah. And radio
yeah, but
waves
I'm talking about ballistics, line of sight.
Are less effective than if they're shot,
We're talking about direct line of sight laser targeting. Direct line of sight.
We're talking about transmission of radio waves, right? Yeah. So it would be lightweight.
You are. No, we're not.
You are.
We're talking about direct line of sight targeting technology. Yeah.
Like what?
Ballistics. And cell towers. My husband climbed cell towers and positioned radios to line of sight to the next cell phone tower. So I know that for a fact, anecdotally. That's not necessarily the best form of proof, but you can also go research this. These people that climb cell phone towers, I guarantee you that they're positioning those radios at the top to the next cell phone tower line of sight. I guarantee
What about military weapons? They do it too.
Yeah, ballistics. This is what I was talking about,
Yeah.
originally.
Yeah, so that's where you get into the nitty gritty, right? And
what nitty gritty?
The nitty gritty of like the expert, right, that we need on the ballistics of the U.S. military, right?
Go for it. Go for it.
I'm not that person.
The U.S. military uses.
Wait, hang on.
What I mean.
But you just said we're getting into nitty gritty, so obviously there's something you don't agree with there. So
no, I'm just
saying. What you don't agree with?
No. I'm saying that there must be a person out there, an expert, right? Maybe not in this chat room. Maybe they're in this chat room, but and if anybody could shed light on this, but
what's the nitty gritty then?
Sir,
so they point.
The nitty gritty is the technology that the U.S. military is using, right?
Yeah, so they point things and then they shoot things at it.
I don't think that you're an expert on that, right? So I don't think you could be the one to tell us that.
Here we go with this expert again. So, can you read?
Yeah.
Yeah? Do you need to be an expert in reading?
Well, tell us what you've read.
I told you that they use line of sight. That's all you need. That's all you need. That they use line of sight.
That's not all I need.
So again, how does line of sight prove the Earth is flat, though?
Wait, one at a time. We're gonna have to deal with SantiagoDunbar first. So, what do you disagree with, Santiago?
I'm not disagreeing with anything yet. At all.
Okay, so line of sight targeting still includes the fact that the ballistics will eventually not just shoot straight, but go down. Is that what you're talking about?
No. I'm just saying that I don't personally, right? Me personally, sitting here, right, talking to you guys, I don't have the knowledge, right, of what weaponry, right, the U.S. military uses, the technology that's involved there, right? And when I use the word nitty gritty,
you don't know.
That's what I was talking about, which is takes long range ballistic missiles, right? And how? Sorry, who's talking?
Yeah, that's all right.
Just let
keep going, mate. No, keep going.
Okay,
mate.
Long range ballistic missiles, right? Whatever technology that the U.S. military has, right? That I'm not privy to. Maybe maybe you've read something about it, right? And you understand the gist of it, okay?
They use lasers. Yeah.
Okay. But so I would like to know those details, but when somebody just says line of sight, isn't that good enough for you? No, it's not good enough for me, right? So then I would say, there should be an expert, right, to talk about it. There could be. And and in some cases, right, you may say that it's privy information, right? It's classified information. a lot of like their missile technology, right?
I can send you a paper if you want. 120 kilometers laser tests done with the military and a university. Would you like that paper?
Yeah. Okay.
Awesome.
Okay. So we're entering into the topic now, if that's what you guys want to talk about. But Timbo, you've read this paper, have you not?
Yeah, I've read the paper. Yeah.
So how is the laser targeting systems? How are they? What is the nuance?
So what they did in this instance was they grabbed 3 different coloured lasers because they're supposed to refract at different rates, and they shot them at a certain height, and they all ended up at the same height at the other end 120 kilometres later, showing that no curvature and they don't refract. So laser targeting, good to go.
What doesn't refract? The missiles themselves?
Well, so if you understood, so the different coloured light is supposed to refract at different rates. So what they did was they did the tests so that they could improve their laser targeting. And what they found out was that they don't refract at different rates, and the height that they left is the height that they ended up at. Therefore, no curvature.
Send me the paper.
Great. Just give me a couple of minutes.
Okay. If you have it on hand, that'd be awesome. If not, if it's too much whatever ridiculous.
No.
I got it.
Yeah. Send it to me, man. Send it to me.
All right. Is there anything else while you're waiting on that?
Oh, no.
Or anybody in the room? Because we got a bunch of people in here.
Yeah, absolutely.
I want to talk about
you throwing this like a non sequitur, or do you understand what they're talking about, or are you just saying you don't know if they can explain it correctly because they're not a professional? I'm just trying to understand where you're coming from.
It's okay. We can prove it.
No. People throw a lot of words out, and those words, right, are just words. Okay, until
that's our problem.
You have
we have that problem.
That's okay.
What words
but like
in particular?
I'm not closed off to the idea whatsoever. I'm not going to. I'm not saying my mind is like.
What words?
Things like line of sight. That's all you need to know.
A gun, shooting a gun.
Okay, so I got you. So we need to prove that it is line of sight. Yeah. So we can prove that it is line of sight. That's fine.
Absolutely. No worries.
What's your name, dude?
So
it's Santiago, isn't it?
Santiago.
Yeah.
Mm-hmm.
I've also been approached by globe earthers, right, who have used theodolites to.
God!
Sorry, man.
Don't get me started.
I know. Okay, so listen. So this person, right, sent me data, and they showed that from all over the world, they had other people doing it in Australia. They had people doing it, in different places. They sent me their own data of
doing
mapping out line of sight from the tops of different peaks that were determined.
You're talking about Ruhif, are you?
Okay, hold on.
Not Ruhif.
Do you know what theodolites are, first and foremost, before you continue?
Ruhif.
Yeah. They're
so you do know what they are?
Yeah.
Okay, so do you know how they have to be calibrated?
What's the max distance?
Honestly,
okay, one at a time. Dudes, just one. Okay. Timbo's taking it. Just let him go.
Sure, go ahead.
No, that's all right. I had one question just while I'm sending this. What's the max distance on a theodolite?
I have no clue. No clue whatsoever.
So how do you know that it's data?
I would imagine. Well, these distances weren't anything extreme. Like 1,000 meters. Right. I don't believe that would be, a max.
So what
distance.
Curvature are they expecting on 1,000 meters?
So they were measuring all these things, and I looked at the data and I scrutinized this, right? And they had error analysis as well, right?
Scrutinized what?
I talked about their error analysis, and based on what they were measuring with the theodolite versus what was recorded as the actual height of that structure in the distance based on an elevation map, right? And they showed me the data saying that there was, I think it was like a 6.7 or like a 7 inches per mile squared curvature. Okay, it's not 8
at 1,000 meters.
Yeah, and some of them were shorter than that. Some of them were longer than that, right? But
sorry, I didn't catch the answer.
Yeah.
Sorry.
would that be a direct measurement of 7-something miles or inches per mile squared, or would that be an interpretation of something else that was measured?
It was an average overall.
No. The drop over distance, the 7-point-something inches per mile squared, right? Would that be a drop that was directly measured, or would that be an inference of something else that was measured?
Direct measurement.
So what was directly measured?
With using a theodolite.
Yeah, using a theodolite. Those directly measure angles.
Yeah, do you know what a theodolite is?
And that angle pertains to height as well.
So that drop that you're talking about would be an inference. Right. That would be an interpretation of something else that was measured, right?
That's the thing. It's a tiny angle, right? Very tiny angle. When you're measuring, 7 inches per mile, right? It's a slight deviation in a assumed flat plane.
What's less than an arc second? So
you're not measuring
less than an arc second.
Yeah, you're measuring arc seconds, right? Which are angles. You're not measuring drop, right? You're interpreting drop from something else that was measured, which would be the angle.
Sure. Right, but it's not straight across, right?
Can I just clarify something with you? Like, when they shot them, were they at like, I know you said elevation, but where did they get their elevations from to know that? Were they on flat ground? Were they on sea level? Like, what was it?
They got them from an elevation map, right? So wherever they took the
they measured
from,
7 inches difference from an elevation map.
Pretty much.
From sea level, how far away from sea level were they?
Well, it's not about sea level. It's about comparing.
Well, that's where they get their elevation.
Yeah, that's how you get the elevation.
No. Elevation is relative. Elevation is relative. You can say something.
No, it's not. Elevation is always done from sea level.
You don't need to compare it to an objective bottom. You don't.
Yes, you do.
Yes, you do.
Non sequitur.
Why do you need to do that?
Because you need a level
where elevation angles come from.
Yeah. You need a level, continuous surface to get an elevation to get an elevation height.
If the ocean is 1,000 feet, right? If they say a mountain is 1,500 feet tall, right, and the peak on the other end is 1,400 feet tall, okay?
Yep.
Those are two measurements, right?
Yeah.
So all you need to know is the difference in height between those two mountains.
Where they measure where they get 1,400 and 1,500 from?
You don't need to know. You don't need to know where the sea level is. It's common for both of them. Okay.
But you need to know the height before you can get the measurement.
It's not about the specific height. It's only about the difference between the two peaks.
So how do you know that it's a difference in height if you don't have the original heights?
Dude,
because the measurement comes from the same place.
No, it doesn't.
No,
it comes from sea level.
is from sea level. Elevation is from sea level. Period.
Right.
There is no other answer.
Before we go too far down into this direction,
we're not going far at all.
No.
I
didn't finish my point. I didn't finish my point, and you're getting me wrong.
Yeah, okay. Go finish it, mate. Go.
I scrutinized this, right? When the person sent it to me, right, I was like,
obviously not good enough.
A million questions, right? The same questions that you're asking me. Okay, I scrutinized the whole thing, and I don't believe, right, what he was showing me. All that I know is that this person apparently did the work, right? Did actual analysis. Apparently. Apparently.
That's an oxymoron. Yes. That's an oxymoron.
No, it's not. He apparently
apparently did it.
Sure, yeah.
Did he actually do it, or did he apparently do it?
He actually apparently did it.
What? That's weird, man.
Know the meanings of words before you say them, but I get what you're saying.
Regardless,
so you're saying that he did the work.
My point is
you're saying that he did the work, and go on.
Right, he did the work. Right, he showed it to me. It doesn't convince me of anything. Okay, really, it doesn't. But
yeah,
what it did show me was that this person's actually out there trying to do his best to prove something, right?
Right.
And
so you don't think that we are?
There are flat earthers. He's a glober. There are flat earthers that are doing the same thing, but I don't see this from everyone out there. Okay, so to me, it's nice to see, right? It's nice to see.
I need you to know what a theodolite is, though. Really quick, I just want you to know what that is. So you have to calibrate that to level, right? Very like it is strict. It's not something that you can take for granted. You have to do the minute. Okay, it has to be level, and some of them calibrate themselves. You can't even bump that thing, or it will be there will be error. So if you're going to use it, you have to use it strategically. And then the optics of the theodolite is not like you would have with like a camera, like a nice zoom in camera. It's not the same. It's meant for a short distance because it's meant to level the ground for construction. So it's not meant to have some sort of like huge line of sight distance to measure. It's meant to do it in increments for leveling a building. So you have to do if the building is big enough, you would have to do it several times with the same instrument because it's not valuable to do it once in a long range distance. You would have to do it multiple times because the optics of the theodolite is not precise enough. Like think about it when you're looking through binoculars that are a cheap set of binoculars, but it's not. Don't get me wrong. Like the theodolite has its own attributes to leveling the surface so that you can get a precise angular measurement for building something.
To me, the data seems fairly...
Okay, let me finish, and then I'll let you talk. I promise. I know it sounds like I'm monologuing, but this is important that you know that the optics on a theodolite are not something that you would use. The optics on the theodolite is not something that you will use in a long range distance. The point of the optics is for short range. You get what I'm saying?
I can understand what you're saying, of course. And I've never used a theodolite.
If they're using them for a large scale of mountains, there's a problem, buddy. And you're going to have to take into the account of the perspective on a smaller scale. You're talking about a small scale of optics that's like zoomed in for a small scale, and use the perspective in that small scale instead of your normal scale like we see in reality. So they're
according to my understanding,
that kind of error. No, they're not accounting for error.
According to my understanding, it's the best instrument for this particular use.
Can I just speak to him for a second? Even if you're doing the 1,000 meters on land, what's your reference point that these two surfaces are exactly at the same height?
It's a relative thing. They're not at the same height, right? They're at different heights. But when
so how are you measuring 7 inches drop and calling it curvature? Why isn't it just 7 inches drop in the land?
Because what you measure, right? The angle that you measure it at,
I know how to use
and what you're pointing at, right? What you're focused on, right? Through the lens of this thing, right? You're pointed directly at the peak of another mountain, right? And the height of that.
You used it for 1,000 meters. You said.
It's very simple. I'll answer your question, but this is not the point. Okay, but there are two
mountains anyway, but it doesn't matter. Yeah.
Sorry? Yep. Sorry, man. You keep interrupting me. But do you have anything else that you want to say other than what you asked me before?
No, you go ahead. But weren't we talking about 1,000 meter measurement?
Something like that. Yeah, I can't remember the exact measurements, but there were some that were shorter. I mean, I could talk a lot about the data that I saw.
Great. But the problem is when you're doing things over land, what you're measuring is the difference in elevation. You're not measuring curvature. You have a starting point on land, and then you take your staff, your story stick, and you go over. You go over, and you put it in a point, and it goes, okay, it's 7 inches lower. So that means that bit is 7 inches lower than that bit. Why is that curvature?
It's curvature because it's supposed to be at a certain height. Okay.
What do you mean? It's supposed to be at a certain height. Are you saying
Parallel.
all land is the same
Please,
height?
please, would you stop interrupting Timbo Slice?
But you're wrong.
Okay?
But you're
Well,
wrong.
I will answer your question once. I'm not going to answer it 3 times.
Go.
Okay?
You've got one
Okay.
staff. I'll give a scenario. You've got your theodolite, and then you've got your staff.
I'm done.
And then you've
Good
got your
luck.
staff 1,000 meters away. What are you measuring? Go. Okay.
You're talking, man. You go. I'll
you
answer
go.
your question, but it seems like you just want to answer your question yourself.
So, with the scenario, can you tell me that? You've got your theodolite there, and then you've got your staff 1,000
Yeah,
meters
it's very
away.
simple.
Yeah,
very
go.
simple. Could I? Okay, thank you. Will you stop talking for 15 seconds?
Already did.
All right, awesome. So look, you're at 1,500 height, 1,500 meters, right? Another thing is at 1,400 meters, okay? You measure, you point it directly at the peak of that thing, right? That's a straight line. And from the theodolite measures from an actual straight line, right? So it measures the angle of difference between these two objects, okay? Now, if that thing were 1,300 meters, right? If there were a 100-meter drop, that angle would be larger. Do you understand? So whatever the recorded heights of these things are, whatever the recorded heights of these things are, if they are not what it says, right? If the angle is different than what it should be, then you have a difference, right? And that difference is a discrepancy. So you guys already said, right? We already went over this. You guys already said the maps are wrong. They're not measured from sea level, or you said that probably, they don't actually know the exact elevation.
Stick to the point, mate.
Right?
You're stick to the point.
They're not.
Finish your story. Finish your story about the mountains. Yep.
I finished it.
Oh,
I'm explaining the whole thing here for you.
Okay, so I just got a question for you. What was the distance between the mountain points?
Many different varying distances.
Okay, just one example then. One example.
There was like over 40 different measurements that were taking place all over the world.
Just one. Mountaintop to mountaintop. One of them, pick one, and we'll go through it if you want.
No, we just did, dude. We don't need to do this again.
No, I want to analyze it with you.
We just analyzed it. There's nothing else to analyze.
But you haven't given me anything. You just said someone grabbed the theodolite. Right. They got two mountains. Right. They measured it different. Can you post it and we can go through it?
I don't have the data. I mean, maybe I do. Maybe I can look back and find the file. But it's been a while. It's been a while. I'm just saying.
If you don't have the data, how do you know it shows what you're claiming it shows? You were pretty confident about the 7-point-something inches per mile squared drop, right? But now you say you don't have the data, so how can you be confident about that conclusion? From data that you don't know.
Data. It's not my data, it's somebody else's.
Yeah, okay, so you don't know the data, so how do you know that the conclusions follow from it?
Oh, because he sent it to me out of the blue.
Because dude sent it to you. You know that his results, his conclusions.
That's right.
Okay, that's stupid.
Grab it, post it, and we can go through it.
Okay. I'll do you one thing. I will look for it. All right, and that's all I can do. I don't know if I have it, but it was months ago. Okay, I'm just telling you this. You guys are kind
pattern.
Me over the story.
It's kind of a reoccurring pattern, though. You guys come here.
I'm telling you an anecdote, right? There are people that actually have done real measurements. Right?
You guys say that. All of you pretty much say that. There are people who've done it, and then we start asking for it, and we don't get the information of who's done it, what exactly they did. It's just somebody else over there must have done it. Some guy sent it to me. I can't remember what it was. Can't remember what he showed. Can't remember what he measured exactly. But I'm sure of the conclusion that the Earth is a globe.
Yeah. See the difference? I came up with an observation with laser tests over 120 kilometres. If you check your DMs, I sent it to you as soon as I said I was going to send it to you. I asked you for your claim, and you can't even tell me what it is.
Well, I was using it as a story, right? I wasn't trying to actually use it as a claim of evidence because, first of all, I don't know these people, right? And like
you were using it as a claim of evidence, though, weren't you?
No. I'm using it as an example of what people do in the flat Earth community and in the globe Earth community. Okay, and I'm using an example of what evidence really isn't. Okay, people on
What
both sides can
evidence
do these.
isn't?
They can do different tests. They can send you information, right? And you weren't there. You didn't actually prove that that the mountains were this height. You don't know all the detailed information that whether
It's
their
not my
camera was
it's
leveled,
not my claim.
whether their satellite was leveled. That's all I'm saying.
It's not my claim.
That's literally all
So-
I'm saying.
What I'm hearing is just sort of a long-winded way of saying, I don't know.
Yeah.
Well, I'm saying that when somebody says line of sight and just listen, this is proof and that kind of thing, it's not good enough for me, right? And just like I brought this up to say that on the other side of things as well, right? I scrutinized
What they were
that.
meaning when they said line of sight is if you can have line of sight and there's supposed to be a hump of curve in the way, then you can't have line of sight. So when you have line of sight and there's supposed to be a hump of curve in the way, it kind of disproves that there's a hump of curve in the way, doesn't it? That's what line of sight is.
Not necessarily.
Begging
Why?
the question.
No, because you're discounting the current model, right?
What current model? Give me the current model. What is it?
The current model is that light bends, right?
Okay, show me that. What's that called? Refraction. Okay, definition of refraction is?
Well, you move light through one medium to another, right? And it will change angle.
Yep. So what's the two mediums?
Air density.
Air
Everything.
and air.
Temperature. No.
Air and
Different densities. Different densities of air based on temperature.
So where's your refraction when you're doing your mountaintop observations? Did you include that in that?
Where's your refraction when you're saying that it's
Always
getting
there.
blocked by a lump of matter?
Refraction is always there.
Good, I agree.
Yeah. So how are you giving us definitive measurements of 7 inches?
No,
when
I'm not.
There's
I'm not-
always
I'm not.
refraction.
No, the only thing that you can see right with your eyes, right, is the light that actually reaches it. Okay.
Yeah, great. So where's the physical part of it then?
Anything that's blocked by physical matter doesn't actually hit your eye. You will never see that thing, right? But
Okay,
if you put a mirror around the corner, right, the light will reflect, right, and
So
you
now
will see
it'll
what's
curve.
in the corner.
Now it'll curve over a hill and bounce off a mirror and curve back over the hill.
No, not all the time. I mean, if it's an actual hill, it won't. But if it's a slow arcing curvature where there is
What's
light
it
that's
refracting
going up
around?
into the atmosphere.
What's it refracting around?
I could draw
What's
you a
it
picture.
refracting around?
It's going straight. Light is going straight, and it's coming from some place, right?
So it's
But
going straight
it might be
over a
going
flat
straight-
surface?
No, it's going straight. It might be I am trying to use the knowledge that we have, right, and
Yeah.
to understand that, and then do away with that. Okay, I'm not trying to say that. I'm not trying to go anywhere else, right?
Yeah, but you just made a claim that refraction brings things up over a hill. Now, I say there's always refraction, but I just want to know where the actual hill is.
No, I said if there is an actual hill, right, it's going to block the light. But if there's a slow arcing of curvature, right?
What if it's a flat surface and the light goes straight? Would it be a flat surface?
It's still
where the light goes
still be refraction. There will still be
Of
refraction.
course, there's always refraction. That's why you can't see 100 miles at sea level, because the light gets refracted. But it's not what you think it is.
Well, I would question that, right?
Okay, well, first of all, you'd need a demonstration of light bending around a ball. Have you got that?
Yeah, a ball, but a ball is like, how large of a ball, right?
Oh, let's say 39.59 miles in radius.
3,000.
We know that refraction. Yeah, try that one.
Yeah. I mean, we have built
a demonstration.
We've built our whole. I think when you look out at a sunset, when you look at all the refraction that takes place in that picture, when you look at a boat going over the horizon, I think, and the distortion on the bottom of the boat, all of that information that you're getting from your eyes is an example of this refractive nature of light.
Yeah, well, where's the physical curve then?
Yeah.
Why wouldn't it be there?
Well,
Where is it?
No, you see. Look. If there was a
Your
slight
you claim
curve,
it's bending
No.
around a curve. I just want to know where the curve is.
I know, but you're going to keep interrupting me. Let me make my point, and then you can talk about that point. Okay. My point is
Don't worry.
if there's 130 miles, okay, of a slight curvature, right? We're at the end of that 130 miles. Technically, you're looking downwards. Something is dropping off. You really shouldn't see something at the end of that, okay? But
Yeah, do you know by how much?
Light from that object. It doesn't matter by how much. Light from that object is going out in all directions, okay? Some of that light is going in an angular direction perpendicular to the curve relative to where it is, right? Relative to where you are.
Can we have a demonstration of that?
Well, hold on. Let me I'm displaying it to you through words, right?
I understand it, mate. I understand.
You said the curve, though. What curve? Can you show us that?
I'm using it as an example, right? As an explanation, and I don't see why this isn't possible. So I'm trying to put it out there to you guys, and then maybe you guys could say why.
What if it's just a flat surface and the light's going straight?
Right. You can say forever, right? You can say what if it's just a flat surface, but I'm also saying instead.
You're just saying what if it's a globe?
Right. And can we talk about that?
Now, where's the proof of the globe? That's what I want to know.
You don't want me to talk about the situation.
What we're doing is, right, so you're saying light bends around a curve. I want to know what it's bending around. It has to be a curve. So where's the physical curve that the light is bending around? It's a simple question.
You've been asking me how it could bend around a curve.
Not how. How. I'm not saying how. I know how. I'm asking where the curve is that it's bending around.
I'm saying it's what you see when you look out with your eyes.
You see a flat surface.
It's flat. Then.
Yeah. We don't see the geometric consequences that we would expect of a globe with a radius of 3,959 miles. We don't see a geometric horizon. We see way further than that should be. So I guess you're talking about light refracting around that curve so that it looks like it's flat or something. Is there any evidence that it's actually doing that, starting with evidence of the curve itself?
Of course there is. It's the definition of refraction.
No, it's not. That's not what I asked for at all. The definition of refraction, that would be the law of refraction. That would be Snell's law, and there's nothing in that tells me that light is bending through air over a curved surface of the Earth.
It actually scatters.
Yeah, that's just wrong. So what I asked for was a measurement of the globe, direct measurement of drop over distance, i.e. curvature of the Earth's surface, preferably a body of water, because that would be equipotential to gravity.
I see what's going on here. Well, you guys aren't really entertaining me, to be honest.
We're not trying to entertain you.
Well, could you entertain me and provide me with measurements of what I asked for? It's only fair. I'm entertaining you, so come on, pay it back.
Yeah, the only...
I said that you aren't, but...
The only argument...
Well, entertain me anyway, please.
You talk about looking onto a horizon when you look right and left. How come you don't see drop?
It doesn't matter. That doesn't matter.
I know.
Before we get too far away, Angle, can we just see about his curvature measurements? Because he seems pretty convinced that light bends around a curved surface of the Earth, curved surface of oceans. So just wondering who measured that curved surface so that we can have the first principle knowledge that that's happening.
He's already by your side.
I was trying to explain that. I was trying to create a model for that with words to explain.
Not a model, please. Don't model it. I want direct measurements of the thing in question.
Well, models require direct measurements, by the way.
It's explaining how it is very, very possible. Okay,
that's a conceptualization. Listen, Santiago, hold on there. I'm not asking for a conceptualization. I'm asking for direct measurements of the thing in question, the Earth itself.
What do you mean direct measurements?
By anybody?
Well, I don't know. Is that Chinese?
Sounds good right now.
Direct measurements.
Yeah. So when you open your eyes and you look at something, right, that is a direct measurement, is it not?
No.
No.
Then what would be?
Direct measurement of drop over distance.
Yes.
That's just an observation. Open my eyes and seeing something is just an observation.
I can look at a square table from the right angle, and it doesn't look like a square. I would have to go up to the table and inspect it further. So it would require me to inspect this further. So yeah, direct measurement of drop over distance is what we're looking for.
If you want to go with observation, just opening our eyes, looking out and seeing something, we don't see that curve, and that's why you've gone to the refraction excuse. That's the whole reason you're talking about refraction, is because we don't see the thing that you're telling us to open up our eyes and see, right? So you wouldn't even need to talk about that. You'd just say, go to the beach, check out the geometric horizon at the ocean, man. That's all you'd have to do. Refraction wouldn't even have to be a topic. So I'm just wondering who measured this thing at the beach that you say light is refracting over?
No, you sound really cool when you say that, but really, refraction, it takes place in every measurement that you're possibly taking.
Dude.
Okay?
I don't care.
How was
There's
the
no
direct
direct
measurement of Earth?
There's no direct measurement that you will ever find that proves something flat that doesn't take into account refraction.
You're obfuscating from the fact that somebody has already claimed that the Earth is curving, so you need to verify that.
Okay, so you're saying that you're talking about measurements put onto us, right? Flat measurements, and you're saying we're not accounting for this thing that you say is going on. Okay, well, the thing that you say is going on.
I'm saying that we're here together, right? No, sorry, Heretic, you were just calling me out for talking about refraction. I'm saying
you were calling
it doesn't
us
matter whether I'm measuring the Earth is curved or whether you're measuring the Earth is flat. Refraction is the most important thing to get straight.
Okay, yeah, cool. But in order for you to have it straight, we need to have a demonstration of that curve that you think light refracts over in the first place. Or else how would you ever know it's doing that? If it hasn't been measured to be there, you got no reason to think that it is or that light's refracting around it. So where's that?
Sure.
Or you can go back to saying use your eyesight.
Let him answer what Heretic said.
Yeah.
At the end of the day, right? There is a model, right? It's how it's there is a physical.
Okay, Santiago. Based on what measurements?
No. Based on having light in a laboratory on a tabletop, right? And this is the behavior of what it does, okay? And understanding that, you extrapolate it to a picture, right? This is a model, right, of what it could do given this atmosphere, given this shape of the Earth, right, and where the light will go. Okay, it is a model. Okay,
could do.
Absolutely.
Could do. Okay, so could do. We're talking about hypotheticals.
Now look, man, I'm trying to lead.
Listen, you're not answering the question though, and you're going on a pretty long tangent while not answering the question. Because I didn't ask for hypotheticals about what light could do in the atmosphere. Didn't ask for that. I asked for direct measurement of what it is doing, starting with the curve that it's supposed to be bending around.
Right. So let me finish. So when you shine a light, okay.
Finish not answering the question.
I am. When you try to take a direct measurement of that light, even if the Earth was flat, there is refraction taking place. Okay. So therefore, even a laser. No, look. You shine a laser at 1 mile. Okay. If you shine a laser at 10 miles, the light that you're getting from that laser has spread. I don't know how many feet. But
I don't
10,
care.
12 feet. Right?
I don't care. If you use a collimator.
Yeah, that's not an answer to the question.
So there's no way to measure
it is.
I don't get it.
It absolutely is, because you're asking for a direct measurement. Okay, you're asking for a direct measurement of curvature.
Yes.
Okay.
Yes.
And even if you were trying to, I'm telling you, even if you were trying to show direct measurement of flatness, you would not be able to.
It's a reversal. I'm just asking for the measurement.
No. The measurement of the ball in the first place if light is always refracting.
Actually, precisely measure flatness with the laser.
Dude, how did you get the measurement of the ball that you're claiming is there in the first place if light is always refracting?
He's a lunatic, man.
Hold on, let him answer.
Hang on,
All right, fine. Sorry.
Answer what?
How'd you get the measurement of the ball if the light is always refracting?
A measurement of the pole?
The ball.
Oh, the balls. No.
Yeah.
I'm talking about measurement in general.
What?
No.
Why?
How did
I asked you a question about a specific measurement. So why are you answering with measurement in general? Just give us the specific measurement. Does it not exist? Is it that hard to directly answer the question, the very specific question I asked? Is there no specific answer for it? Is that why you're tap dancing around it?
No, because you're being kind of a hard ass about this question, but really when you apply it to things of the flat earth nature, the flat earth community, it's the same issue.
Why are you doing that?
Because you're asking for something even more ridiculous, right? And I'm saying I'm strongman you saying
I agree with you.
But they gave us a measurement. They gave us a measurement
that can prove that it's flat, right? You can't because
I just sent you. I sent you laser tests over 120 kilometers.
And I don't have to anyway, because axiomatically it's not what anybody experiences. When we go to the beach, we don't see the geometric horizon that should arise from that globe that we've been told we live on, right? And that's why you guys have to start talking about refraction. So we just don't see that globe in reality. So I don't really have to do anything because you're the one in here telling us that what we see isn't what it actually is. So you got any proof of that or not?
No, because I was saying the same exact thing as you. I was saying go look with your eyes,
taking
right?
the middle ground fallacy, dude.
What you're seeing,
doing,
right?
You're assuming the compromise between two positions, dude.
Just let him answer.
But it's light being refracted around a curve, and you see it as a straight line of sight, perpendicular direction. But it's not.
Yep.
The light is actually coming from a place where it's tangential to where it curved from.
How do you know that?
Where is the curve measured that it's going around?
All mirages work.
How do you know that?
It's like saying, I've got this zigzag. I haven't proved the zigzag, but I know the light is going over the zigzag because I can see it.
No, it's like saying, right, if light were being curved, right, you would only see the top of that curve. That's the light that would reach your eye.
Can we have a demonstration of this?
Now that's all that I'm saying. So you could say that.
Can we have a demonstration of it? You're making a claim. You're making a big claim. So do you have a demonstration actually proving this point?
I think that light is being curved based on these.
Hey, dude, what's your proof that the light is being curved over a curve?
What's your proof, man?
That's a burden reversal.
Yeah.
You're the one saying that what we see isn't what we actually get. You're saying that what we see is something other than what it actually is, right? And then every single time we ask you, well, how do you know that? You just go, well, prove it is what we see it as. That's stupid.
Well, no, I'm saying that this is the nature of light, right? This is how it behaves. Right?
Yeah, we're not asking about light. We're asking about the physical ball that it's going around.
No. I'm talking about the physical nature of light, right? Which you guys are using for your own purposes when you want to, and in other circumstances, you're totally disregarding it. And
no, all as we're asking for is the physical ball that you're claiming the light goes around. That's all. I don't care about the light.
Yeah, dude. You haven't given us anything to disregard. Listen, I've been asking you for the measurements that validate the things that you are saying about what light does over the Earth, right? And you haven't given me anything to disregard. So what are you talking about?
I'm not an angry person here, okay? I don't want to get into
no one's getting angry, man.
Look, every answer you give.
I don't like these. I personally don't. I'm not interested in these types of conversations. I've done them for months. They're not interesting.
Then why do you do them for months, and why are you still here doing them? Just fuck off if it's not interesting. Because we just want one thing that you can't seem to provide us. So I don't know.
I didn't mean to get into this topic, or to this type of argument. But it's it's reacting to a lot of you guys' attacks, right? That has led me to this.
Okay. It's another feel. Hey, the feeling servers down the road.
Classic Flag, you've been pretty good. Here's
the thing.
Yeah, but Santiago, you haven't been very good, though, because you keep saying things and then you try to bullshit your way around it when we just go, well, how do you know that? That's all we're asking is, well, how do you know that? You say that light was tangential to the curve of the Earth where it traveled from to reach your eye. Right? Okay, so there's supposed to be, geometrically speaking, a tangent point at 1.2 miles for a 1-foot observer. Instead, I see what you're calling a tangent point out at 10 miles, right? So I'm just asking how you know that 10-mile tangent point is an illusion, and there's actually a physical geometric 1.2-mile one there. I'm just wondering how you know that.
Heretic, I tried to explain my view of it, right, based on my knowledge of physics, but I was interrupted over and over and over again by more attacks, more questions,
See,
right?
you're
So I
not
wasn't
answering.
even able to make that point.
You're not answering.
Again, like what you're saying
That's
right
not
now.
an answer. That's not an answer.
Can I go back and try to explain the point that I tried to explain 10 minutes ago?
No, can you just answer the questions that we're asking? Because I'm interrupting you right now because once again you're responding completely non sequitur to what I just said.
Because I'm making a point that you are interrupting me, right? With
no,
more
you're not making a point. I asked you a pointed question. You went off on a ramble, not answering it, right?
Okay,
that's why I keep cutting in. If you just answered the questions I'm asking, I would just shut up and listen.
I'm going to answer it. Okay. There's a 130-mile distance. Okay. There is a slight curvature over those 130 miles. Okay. Something is viewing from one end, and there's an object at the other end. Okay. Now, with just pure imagination, if this imagination was going out in a straight line, it would not be able to see what's 130 miles away underneath the curve. Okay. Because the Earth drops a little bit, you can't really see what's there. Okay. But the way that light behaves is that object is shooting light out in all directions. And some of those light waves are going perpendicular for it, tangent to the Earth, right? Which means that for the other person, they're going up at this obtuse angle into the sky. Okay,
dude, this isn't an answer.
You're doing it again.
You're doing it again.
No, you're doing it again. Be quiet, Santiago.
You're doing it again.
Be quiet, Santiago. You're doing it again. Because I asked you a pointed, specific question. Like, for example, I see a 10-mile horizon where, geometrically speaking, according to you, if the Earth is what you say it is, there should be a 1.2-mile horizon. You say that light took a deflected or diverted path around that curve, so I saw it as something other than what it is. All I asked you is how you know that.
I'm explaining the model, right, which is knowledge. Which knowledge, I understand that knowledge can be wrong.
How do you know what I just said?
I'm trying to explain it to you. And
how do you know that things are something other than what they appear to be to us? How do you know that? How do you know what they actually are instead of what we see them as?
I don't.
Okay, thank you.
After all that.
Okay, are we ready to switch topics now, or what?
Yeah, that's fine. Thank you, Santiago, for just answering.
I think so. Yeah. He just admitted after an hour that he doesn't know.
Well, I appreciate it nonetheless.
No, I question knowledge at all, but you guys aren't really even interested in any knowledge whatsoever.
Well, I am. If you would have just given me the answer, I would have been really interested in that. But you did give me an answer. I don't know it's valid.
Your own subjective point of view, whatever the hell that may be.
No, I'm not.
Yeah, you are.
It's completely backwards. That's you've got it completely backwards. I just
looking into it, right?
Yeah, that's what I'm doing, Santiago. That's what I'm doing. That's what I'm doing. I'm looking into it. I'm seeking the objective knowledge that you claim to have. That's what I'm doing. That's why I'm asking you these questions, and that's why I keep interrupting when I get an answer that isn't actually an answer.
All right. Yeah, let's move on.
Are we ready to switch topics?
Conversation. You're not interested in actually any other thing other than what you want to say.
You don't need to psychoanalyze me. Okay, he left.
I'm just going to summarize.
Did he leave just now?
Yeah.
I'll just summarize what happened. So he's trying to explain light around a curve that the curve he hasn't proved yet, but keeps on explaining light bends. But it bends around a curve because we can see it at a further distance than what it is predicted. Therefore, light curves around a ball because we can see further than is predicted.
What is your profession?
See, old friend, I brought more soldiers than you did.